Thevenin's theorem. What is the statement of Thevenin's theorem? Thevenin's theorem. What is the statement of Thevenin's statement? Theorem. Statement. So in any linear bilateral active network, current flowing through a load resistance RL connected across the terminal A and B of a network, and it is given by VTH divided by RTH plus RL, where VTH is the open circuit voltage, that is voltage across the two terminals when load resistance RL is removed, and RTH is the Thevenin equivalent resistance of the network as viewed back into the network from the terminals A and B, with all sources are replaced by their internal resistance. That is the statement of theorem. So you can write like this. This is your linear bilateral active network. Okay, this is linear bilateral active network. Okay, this is the output terminal. In this output terminal, we are connected the load terminals, that is RL, AB. Then this network can be replaced by a 1 voltage that we can call as a open circuit voltage, or we can call as a Thevenin voltage. So how we are finding the Thevenin voltage means you have to remove the load terminals, find out what is the open circuit voltage. That open circuit voltage will give the Thevenin voltage in series with the resistance, that is called as a RTH, in series with the resistance RTH. So how we are finding the RTH, Thevenin resistance, means open the load terminals, that is RL. If it is a voltage sources, short the voltage sources. If it is a current source in the network, open the current source. Looking from the terminal A and B, what is the total resistance or equivalent resistance? That gives your Thevenin resistance. Then whatever given the load, that will be connected across the load terminal RL, that is AB. Okay, here the point node is AB, and current flowing through the load resistance is given by IL is equal to VTH divided by RTH plus RL. The current flowing through the resistor is given by IL is equal to VTH divided by RTH plus RL. This is the statement of theorem. That means in any linear bilateral active network, the current flowing through a load resistance RL connected across the load terminal A and B of a network is given by VTH divided by RTH plus RL, where VTH is the open circuit voltage, that is voltage across the load terminals when the load resistance RL is removed, and the RTH is the Thevenin resistance, that is equivalent resistance of the network as viewed from the network from the terminals A and B, with all sources are replaced by their internal resistance. That means if the voltage sources, short the voltage source. If it is the current source, open the current source. Calculate what is the equivalent resistance. That equivalent resistance itself is the Thevenin resistance. So what is the procedure to follow to determine the Thevenin voltage and the Thevenin resistance? Means this is the procedure. What I explained so far now, that is the procedure. So I'll explain once again what is the procedure means. Open the load terminals, find out what is the open circuit voltage. That open circuit voltage will be gives the Thevenin voltage. Okay. Remove the load terminals. If it is a voltage source, short the voltage source. If it is a current source, open the current source. Then looking from this terminal, calculate what is the total resistance or equivalent resistance. The total resistance will gives the Thevenin resistance. So to understand this, you solve the one problem. The question is like this. Find the current through the load when RL is equal to 1 ohm and RL is equal to 13 using the Thevenin's theorem. So this is the circuit now here. This is positive, negative. and here you can connect one resistance here, and here also one resistance. Okay, and here there will be a one current source. It is connected like this. This is where 10 volt, and this is the 2 ohm, and here it is a 1 ohm, and this is a point A and B. This is a point A and B. A and B. This is where 10 amps, and this is where 2 amps, and this is the load resistance RL. RL. So the problem is find the current through the load RL. Okay, is given the two values, that is RL is equal to 1 ohm and RL is equal to 13 ohm. Then for this values find out what is the load current by using the Thevenin's theorem. Okay, this you can simplify. First you can do one thing. This you can rewrite, and you have to use the source transformation. Now here voltage and current. So here they are connected now here. This is the voltage and current now here. This is the voltage source. This you converted into current source. Okay. This you converted to current source. So how to convert the current source? So you can convert like this. You can write like this. I is equal to V by R. So here minus plus no. Therefore you have to write direction like this. If it is minus plus, then you can write downward. Direction should change. Now in this case, I is equal to V by R. V is 10 and R is 2. Therefore it is a 5 amps. This is 5 amps. And whatever the resistance 2 ohms, that will becomes in parallel. Parallel. This is the current source. If you convert it to voltage source, you will get back the same previous one. And this is where 2 ohm. And here this, that is 10 amps is connected to this and this node. Instead of connecting this, I can rewrite like this. That is, I'll connect it the same node, but to solve the problem, I'm writing like this. So the circuit will not change because it is connected to here node and node only. I've connected the same node. And again, this is another 2 ohm resistance is there, that you write a 2 ohm resistance here, 2 ohm. Okay. And here there will be a 1 ohm resistance is there, that you write. This is the point, it is A, and this is the B. And here the load resistance. You can remove the load resistance. Okay. Now what you can do next? What is the next procedure? Now this current 5 amps and 10 amps are connected in the same direction. Therefore, we can add the current. So there becomes here 12 amps. This is 12 amps.
Yes, sir.
And 2 ohm are connected in parallel. What is the total resistance? 1 ohm. 2 ohm, it is connected parallel now, 2 and 2 ohm. Therefore, this becomes a 1 ohm.
Sir, it becomes 15 amps, sir. 10 plus 5.
15 amps. Okay. This is total current will be 15 amps because it is 10 plus 5, 15 amps. This is a 15 amps. And 2 ohm are connected parallel, that is a 1 ohm, and remaining resistance is there, that you are right, 1 ohm, and here it is 1 ohm. This is a point, it is A and B. Okay, now you further simplify this. If you further simplify, then what you can do right now here, after simplification further here, this is voltage, this is the current source. No, this is converted into voltage source. Now this is your, this is a current source, right? This is converted into voltage source. Now then you connect the voltage source, this becomes minus plus because the direction is like this. No, therefore this is minus plus. V is equal to I into R. So V is equal to I into R. Here I is V is 15 into R value is 1. Therefore this becomes a 15 volt. This is a 15 volt. And whatever the resistance parallel now in voltage source, it will comes in series 1 ohm, another 1 ohm, that is 1 ohm is there, that you connected. This is the point, it is A and B. If you further you simplify this, now this is the positive negative, and these are resistance are in series, 1 ohm 1 ohm in series. Therefore this becomes a 2 ohm, and this is the point A and B. Now, while reducing, this network reduces itself as a Thevenin circuit. What is a Thevenin circuit? Thevenin circuit contain one voltage source in series with the resistance. It forms a Thevenin circuit only. Therefore, Thevenin voltage will be 15 volt and Thevenin resistance will be 2 ohm. Okay, 2 ohm. So now he has given the RL value as a 2 value as given. That RL you can connect here. That is RL first is given as a 1 ohm. For that 1 ohm RL, what can I find out what is the IL? IL. First case RL is equal to 1 ohm. For this value, IL is given by what is the formula? VTH divided by RTH plus RL. So this is VTH is 15, RTH is 1 plus 2, 3, that is 5 amps. For the second case, what is RL? RL is equal to another value is given 13 ohm. 13 ohm. And for this, what is IL? IL is equal to VTH again. VTH divided by RTH plus RL. So VTH is how much for this case? What is the VTH? So VTH is again 15. RTH is 1 ohm. What is the RL is given? 13.
1.07, sir.
RL is 1 ohm and RT is given
2 ohm, sir.
2 ohm,
13,
but
sir.
RL ohm is given 13, therefore 15, that is a 1 ohm. That is 1 ohm. Okay. Now we calculated. According to procedure, you calculate and tell me the answer. You'll get a same only. Try out.
Whether RTH is 2 or 1, sir? Sir?
Calculated. Hmm?
Yes, sir. It's same, sir.
Same only, no? Because so what is the RTH? To calculate RTH, what I explained into, suppose if you want to calculate the procedure, no, yeah. So one voltage source is there, no? So you have to short the voltage source. Resistance is there, that you have to resistance, and open the current source. If it is open, that is open, there is no necessity of writing this, so that we will get a circuit like this. Suppose if you want to find out according to procedure RTH, okay, what you have to according to procedure, short the voltage source, open the current source. What is the remaining circuit? This is a 2 ohm and here it is a 1 ohm and it is a 2 ohm. Now looking from this terminal, calculate what is the total resistance. Now 2 ohm, 2 ohm are connected in parallel now. So this becomes 2 ohm parallel with the 2, that becomes 1 ohm, and again another 1 ohm. This will be in series, and this is the now RTH. Now these are connected in series now, therefore RTH is equal to how much? 2 ohm. We got directly, after reducing we got a 2 ohm only. And find out what is the open circuit voltage. What is the open circuit voltage when you find out right now? Remove the load terminals. Okay. And if you take this circuit, after reducing now, after reducing, what is the circuit we got? We got this circuit now here to find VOC. To find open circuit voltage. So this is the circuit we got now after reducing, plus negative, and this is the resistance, and here it is 15 volt, okay, and this is a 2 ohm. This is a point, it is AB. Open circuit voltage is nothing but a VAB. This itself is a Thevenin voltage. Because it is open circuit, there is no drop, only the voltage across the 15 volt. If you measure the voltage, you will get a 15 volt. Therefore, VTH will be 15 volt. This we can solve by using nodal analysis also, same problem. By using the nodal analysis, we can solve this problem. There are so many methods to solve the problems. You can use any one method, but answer will be same for all the method. Okay, so this is the circuit here now. The original circuit is this. This is where 10 volt, and here it will be that resistance. It is now 2 ohm, and here from here to here they're connected one resistance here, that is our 2 ohm, and here there will be a current source, right? Okay, and here will be a resistance, and it has opened. So this is opened, so that is, here you can take the node as a V1, mark the node as a V1. Now apply KCL. For nodal analysis we have to apply the KCL. What is the current flowing through this branch? So what is the current flowing through this branch? What is the current flowing through this branch? That is V1 minus 10 divided by 2. Suppose if it is minus plus, then you have to write V1 plus 10 by 2. If it is plus minus, then you can write V1 minus 10 by 2. Current is entering the node. What is the current value is given? How much is given? 10 amps. 10 amps. In the original circuit, they are given a current as a 10 amp. Entering the node, minus 10. If it is leaving the node, plus 10. It is entering the node, it's therefore it is a minus 10 plus. What is the current flowing through this branch? Another branch. Current flowing through this branch, that is V1 by 2. That is V1 by 2. V1 by 2, that is equal to 0. There, what is the current flowing in this branch? Because it's open circuit, there is no current flowing in this another resistance. Okay, here 1 ohm resistor branch, there is no current flowing because it's open circuit, therefore we can neglect this. Now 2 as a common factor, then it is V1 minus 10 minus 20 plus V1. Okay, V1 is equal to 0. This we can write it as a 2V1 minus 30 is equal to 0. 2 into 0 0, and therefore V1 is equal to 30 divided by 2, that is equal to 15 volt. So what is a V1 here? V1 is nothing but a voltage across the 2 ohm. That itself is a open circuit voltage. That's a V1 is nothing but a voltage across AB. So V1 is nothing but a voltage across the AB. That is our open circuit voltage. That itself is a Thevenin voltage. That is our 15 volt. Again for RTH, what is RTH now? For the same procedure, RTH, to find RTH, again short the voltage source, right? Resistance is there, open the current source. Then it is here one more resistance is there that you have to write. This is your 2 ohm and this is the 1 ohm and this is the 2 ohm. Here 2 ohm parallel. So therefore this becomes a 1 ohm and here as a 1 ohm because this is a 2 ohm parallel with a 2 and this is the resistance here. Then this becomes a 2 ohm. Resistance is 2 ohm. This is our RTH. You can find like this also. Then write a circuit for open circuit voltage, Thevenin resistance and load resistance. Then you calculate what is the current flowing through the load resistance. Okay. Any doubts? Raghunandan. Hello.
No, sir.
Okay. Shall I go to the next problem?
Yes, sir.
Now down next. Obtain the Thevenin's equivalent of network shown in figure. Obtain the Thevenin's equivalent of network shown in figure. Obtain the Thevenin's equivalent of network shown in figure. This is a circuit. This is positive, negative, and then this is the resistance, and then this is our inductance, and this is the here capacitor. Okay, and it is here 10 ohm, and this is 10 at an angle of 0 degree volt, and this is 3 ohm, and this is J4 ohm, and this is minus J10 ohm, and this is the terminal EB. Okay, find out this. This is becomes a loop now. You can assume the loop current. To find a Z equivalent, that is total impedance. How to find out? Short the voltage source. Write a remaining circuit. So remaining circuit will be like this. So this is our 10 ohm, and this is a 3 ohm, and this is our J4 ohm, and this is minus J10 ohm. Looking from this terminal, what is the equivalent impedance? You have to calculate. That equivalent impedance, it will give your Thevenin impedance. Now 3 plus, what is the Z equivalent now here? Z equivalent is equal to 3 plus J4, that is in series, 3 plus J4, okay. This will be in parallel to the 10 ohm. Whatever coming now, that will be in series with the capacitor minus J10. That gives your equivalent total impedance or equivalent impedance. Looking from the load terminals, calculate what is the total impedance. 3 plus J4 parallel with the 10. Whatever coming that will be in series with the minus J10. Now we calculate this. This is 3 plus J4 into 10 divided by 3 plus J4 plus 10, Z1 into Z2 divided by Z1 plus Z2 minus J10. Okay, now calculate this. This we can multiply directly. We can convert a polar to rectangular to polar to rectangular. Otherwise, you can multiply. 10 into 3, that becomes a 30 plus J 40. Below this is 13 plus J4 and it is minus J10. Further, you simplify this. What is the 30 plus J40?
At an angle 53.130.
Okay, 50 at an angle of 53.13. 53.13 divided by 13 plus J4, that is 13.6 at an angle of
60 at
17
an angle 17.10.
With minus J10. Now, when it is formed like this, then you have to take 50 by 13.6 and the angle should be subtract 53.13 minus of 17.1. So that is how much? 3.676 at an angle of 36.12 minus J10. Now we can't add directly this. Now it is this polar form convert into rectangular. So when you convert into rectangular, then we will get 2.969 plus J 2.167 minus J10. After simplification, this will get 2.969, okay, minus J 7.83 ohm. This is your Z equivalent. This is your Z equivalent. Then you find out a Thevenin voltage. To find Thevenin voltage, VTH you have to find out. Z equivalent is a Thevenin impedance. Find out VTH you have to find out. How to find out a VTH now here? This is a circuit. This is your positive negative, okay, is given, and here it is a 3 ohm, it is 3 ohm, and it is a inductance here, it is connected here, and here this is your 10 ohm, and it is 10 at an angle of 0 degree volt, and it is 3 ohm, and it is J4 ohm, and it is here minus J10 ohm, and this is the point, it is A, and this is the point, it is B. Okay. Open circuit voltage VAB, voltage across the J10 ohm, voltage across the 3 plus J4 ohm. That gives your open circuit voltage, that is a Thevenin voltage. But it is open circuit, no, there is no drop across the minus J10 ohm, only drop across the 3 plus J4 ohm. How to find out what is a drop across 3 plus J4 ohm? This becomes a loop now here, left hand side, you can assume the loop current, apply KVL. Apply KVL. When I apply the KVL, we can write it as 3 plus J4 into I minus 10 plus 10I is equal to 0. This we can write it as add 13 plus J4 into I, that is equal to 10. So therefore, current I is equal to 10 divided by 13 plus J4. So the further you simplify, this is 10 at an angle of 0 degree, 13 plus J4, if you convert this, this becomes a 13.6 at an angle of 17.102. After further simplification, I is equal to 0.735 at an angle of minus 17.102 degree amps. This is the current. So what is a Thevenin voltage? Thevenin voltage is nothing but a VAB, that is nothing but a Thevenin voltage, that it is 3 plus J4 into I. drop across that, and drop across minus J10, but it is no open circuit, there is no current flow, there is no drop, only drop across the 3 plus J4. So this is equal to 3 plus J4 into I is 0.735 at an angle of minus 17.102. So much for this after simplification. What is the value? VAB. Again convert this. If you want to multiply means 3 plus J4 you have to convert. That is 5 at an angle of 53.13. 53.13 into 0.735 at an angle of minus 17.102. How much it is?
3.675 at an angle 36.028.
676 at an angle of 36.12 degree volt. He asked only the what is the Thevenin equivalent. So what is the Thevenin equivalent? This is Thevenin voltage now here. Thevenin voltage, that is 3.676 at an angle of 36.12, and the Thevenin impedance that you have to write. So Thevenin impedance is how much you got? 2.969. 2.969 minus J 7.83 ohm. He has not asked current flowing through the load because he has not given load, but he asked only the Thevenin circuit. This is the Thevenin circuit. Is it clear?
Sir.
Yes, sir.
Next, what he has solved this problem is no, it contains independent voltage and current sources. Suppose if it is having the circuit contains a dependent voltage source or dependent current source, then what is the procedure to calculate the Thevenin resistance and uh, Thevenin voltage? So this is the procedure to calculate. First procedure is determine the open circuit voltage. Determine the open circuit voltage. Open circuit voltage VOC with the sources activated. Second point, find the short circuit current. Find the short circuit current. That is ISC when a short circuit is applied to the terminals AB. Then Thevenin resistance is given by open circuit voltage divided by short circuit current. This is the procedure as to follow if the circuit contains a dependent voltage and current sources. That means the circuit contains resistor, dependent and independent sources. Then this procedure has to follow to calculate the open circuit voltage and the Thevenin resistance. To understand this in here, you note on the one problem. Find the Thevenin equivalent. For the circuit shown in figure. With respect to terminals AB. This is your positive, negative. This is the circuit node of resistance, and here it is. This is minus plus, and this is 2I. and here there will be a resistance here, and here also resistance, and this is A, and this is your B. This is your 20 volt, and this is 6 ohm, and this is 10 ohm, and this is a 6 ohm, and this is your I. Here it is given as a I. Now find out what is open circuit voltage. To find open circuit voltage, that is your Thevenin voltage, that is nothing but voltage across AB. I told you now you have to find out open circuit voltage with sources activated in this case. What are the figure you write? Plus minus, this is 20 volt, and this is your resistance, it is 6 ohm, and it is there here minus plus, this is your 2I, and here this is resistance here, and this is your 6 ohm, and this is your I. Okay, and here it is resistance, it is 10 ohm, and this is the point, it is A and B. It's the A and this is the B. Now what is the open circuit voltage VAB? VAB is voltage across a 10 ohm and voltage across a 6 ohm. But it is open circuited and there is no current flowing through the 10 ohm resistance. There is no drop. Therefore, you have to consider only voltage across the 6 ohm only. How to calculate as voltage at 6 ohm? You have to find out what is the current flowing through the 6 ohm. To calculate, this becomes a loop now here. Assume the loop current. Anyhow is given I only. You can take loop current as I only in this loop. Then apply KVL. Apply KVL. When apply the KVL, we can write it as a 6 into I minus 2I plus 6I minus 20 is equal to 0. This is 10I is equal to 20. So therefore, what is I? I is equal to 2 amps. 20 by 10, 2 amps. Then what is the Thevenin voltage? Thevenin voltage is nothing but a VAB, that is equal to 6 into I, that is equal to 6 into 2, that is equal to 12 volt. This is 12 volt. Next, you have to find out a short RTH. To find RTH, to find Thevenin resistance. To find out a resistance here, RTH, here you have to short the output terminals, find out the short circuit current. This is where minus plus, this is a 2I, this is where 6 ohm, and this is a 20 volt, and here there will be a one resistance is there, that resistance you write. This is here current, it is I, and here it is a 6 ohm, and here it is 10 ohm. This is the terminal, you have to short this terminal. Okay, and this you can take this as AB, and this is your short circuit current. Okay, find out what is the short circuit current in this. Now in this example there will be a two loops, therefore you can assume the loop current. This you can take as a I1, And here you can take I2 or ISC. Anyhow is given already ISC. You can take the same notation. ISC only you can take. Now apply KVL for the mesh 1. Apply KVL. Apply KVL for mesh 1. Mesh 1. Then we can write it as a 6 into I1. Okay. Minus 2 into I plus 6 into what is the current flowing in that branch? Two currents are there. I1
I1
minus
minus ISC.
ISC minus 20 is equal to 0. But looking from the diagram, what is I? I is equal to current flowing through the 6 ohm resistance. What is the current flowing the 6 ohm resistance is I. What is the current flowing through that branch? I1 minus ISC. Therefore, I is equal to I1 minus ISC. Because in this branch I1 is flowing, IC is flowing, ISC is opposite of the I1. Therefore, you have to take I1 minus ISC. That is current flowing the 6 ohm. In the diagram is given current flowing the 6 ohm is I. Therefore, I is equal to I1 minus ISC. This is substitute in the above equation. That is 6I1 minus 2 into I1 minus ISC plus 6I1 minus 6ISC is equal to 20. Further, you simplify this 6I1 minus 2I1 plus 2ISC plus 6I1 minus 6ISC is equal to 20. Further, if you simplify 6,
1
12,
minus 4
10I1,
ISC
10I1,
minus 4 ISC is
10I1
equal to 20.
minus 4ISC is equal to 20. Call this equation as a 1. Next, apply KVL for the loop 2. Apply KVL for loop 2. When apply the KVL for the loop 2, then we can write it as a 10 into ISC plus 6 into. Now, when you are writing the loop equations, you have to consider that current first. Earlier, we have
ISC
considered I1
minus
first,
I1
and now it is ISC. You have to consider ISC.
minus I1.
Current flowing that is ISC minus I1. ISC minus I1 is equal to 0. That is minus 6I1 plus 16 ISC is equal to 0. Now this is the second equation. Now if you solve the equations 1 and 2, then you'll get what is the ISC. What is ISC after solving this? Calculate.
Sir, I1 is 1.17 and ISC is 0.44.
ISC?
0.44.
Huh?
0.441.
0.88.
Yes, sir. 0.8823.
0.88 amps. 0.88 amps. That is
Yes, sir.
ISC. So what is the Thevenin resistance? Thevenin resistance is given by open circuit voltage by short
0.88.
circuit current. So open circuit voltage is 12 and short circuit current is 0.88. That gives you 13.63
13.636.
13.63 ohm. 63 ohm. This is the answer. So you have to calculate a Thevenin resistance and a Thevenin voltage by using this procedure when it is connected dependent sources and independent sources and also a resistor.